Hello, I welcome you all to this another interesting screencast. The problem reads, the horizontal 30 newtons force acts on the handle of the wrench. What is the magnitude of the moment of this force about the z-axis? The second case is the horizontal 30 newtons force acts on the handle of the wrench. Determine the moment of this force about point O. Specify the coordinate directional angles alpha, beta, gamma of the moment axis. Both these problems are coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So you can solve this particular problem by either using the vector or scalar analysis. It's really up to you to choose which approach you want. I'm going to go with the vector analysis. So let's start with writing down the components of this particular force. So we'll have this component there, and then we'll have this other component there. Okay, this component here is going to be equal to this. Okay, since they are all at 45 degrees from each other, this, if we term this one cos 45, then the other one we can term it as sine. All right. Okay, and this is just going to be equal to 30 sine cos 45. We'll write it as 21.2132. It's the same thing with this. 21.2132. All right. Coordinates for A. Let's write down the moment arm. ROA is just equal to RA, which is just equal to what is the direction in the x-axis is minus this 10 here. You've seen this 10, seen the negative, so converting it to meters is 0.01 I. And then we have in the y-axis it is a 200 positive, which is just a 0.2 J. And then in the z-axis is a plus 0.05 K. All right. And then one more thing, we'll need the moment about the z-axis. So I'll need to multiply, to dot this with the unit vector along the z-axis. Okay, so unit vector along it is just equal to K. All right. Okay, great. So now let's start with the first case. Case 4-164. So we have been asked to find the moment about the z-axis. Like I said, you could go directly and use the scalar, or you can use the vector analysis. We are going to go with the vector. So say moment vector about point O is going to be equal to RA cross the force. Okay, and then let me just write down the force. Our force vector is just equal to positive 21.2132 I, and then we have a minus 21.2132 J. Okay, so there we go. Therefore, our moment about the Z axis is just going to be equal to the unit vector along the Z axis dot RA cross F. Okay, so writing this in just one operator, this we're going to have a scalar. This is moment about the Z axis as a scalar. So if we were to plug this in, we have u, which is just equal to 0, 0, 1, and then we have RA. It is minus 0.01, and then 0.2, and then 0.05, right? And then we have F. F is just a 21.2132, then a minus 21.2132, then a 0. So we have a 0, of course it's just all 0. Let's just write it as 0. It's moving. Then minus, second part is also 0, plus, there we have a 1. 1, that is 0.01, both minuses, they become plus 21.2132 minus 0.2 by 21.2132. So this gives us a minus 4.0305. Okay, so therefore our MZ is just going to be equal to minus 4.03. Okay, the units is Newton meters. So this minus just indicates that the moment is facing downwards along the Z axis, like so, okay, using the right hand thumb rule. Okay, let me just, alright, there we go. So we are done with the first case. Let's go to the second case. So the second case, we are being asked, yes, let me just write 4-165. So here we have been asked to determine the moment about point O, and after that we specify the coordinate direction angles. So moment about point O, again we are just using this particular tool which we partially did already. We have I, J, K, we have minus 0.01, then 0.2, then 0.05. so this is, we wrote already the equation for moment about this one, their moment about point O. Okay, and then the force, we already have it, 21.32, and 21 minus, okay, let me just write it. So 21.2132 minus 21.2132, and then a 0. Okay, so there we go, we have an I there. I, that's a 0 minus 0.05 by 21.31, 2132. So this one gives us a plus 1.06. All right, and then we have minus j. We have a 0, and then this one minus, so it gives us the same, which is just minus 1.06. Okay. And then we have a plus k. We have this one 0.1 is the same value that we found, which is a 4, but we can still multiply 21.2132 minus 0.2 by 21.2132. So we have a minus 4.03. Therefore, our moment about point O is equal to 1.06 I plus 1.06 J plus minus 4.03 K. Okay, Newton meters. Right, but we are not yet done. We have been asked to find the coordinate directional angle, so let's find the magnitude. So magnitude of this is just going to be equal to 1.06 squared cos times 2 plus 4.03 squared, so square root of that, so we have a 4.3. okay, 1.06 4.03. right, so the unit vector along this moment axis is going to be equal to the moment vector itself divided by its magnitude, which is just going to be equal to this is going to be equal to 1.06 divided by 4.3 I plus 1.06 divided by 4.3 J minus 4.03 divided by 4.3 K. Then the cos alpha being the angle between the moment itself and the positive x-axis, is going to be equal to cos alpha is going to be equal to cos beta. They have the same values. It's equal to 1.06 divided by 4.3, and therefore alpha is equal to beta, which is equal to 1.06 divided by 4.3. Cos inverse of that, it gives us a 75.73 degrees. Then cos gamma, so beta is the angle between the positive y-axis and the moment vector. Alpha is the angle between the positive x-axis and the moment vector. Gamma is the angle between the moment vector and the positive z-axis. This is equal to minus 4.03 divided by 4.3. Gamma, therefore, is just going to be equal to 4.03 minus 4.03 divided by 4.3. Okay, cos inverse of that gives us a 159.59 degrees. Alright, Guess we are done. So we have the moment about the z axis. This is the magnitude. It's pointing down using the right hand thumb rule. That's the reason we have a negative. And then we have the moment itself about point O expressed as a vector, and we've also calculated this magnitude. So there we go. Okay. Sorry. Just trying to lower down the line. Okay, something like that. So that is the final solution. Okay. And then we have this magnitude. There we go. See the magnitude. And then we have the angles, directional angles along the axis of the moment vector. And then we have the gamma also, alpha, beta, and gamma there, which are all directional angles. All right. I think this is about it. And I hope the video is helpful. And if it was, give me a thumbs up or like my video. Continue subscribing and liking my channel. Bye bye, and see you in my next screencast.